Welcome to Stage 1 Mathematics, Growth and Decay. In the next series of videos, we're going to have a look at the topic of surds. So jumping into it, root A is the non-negative number such that root A times root A equals A. And we find that the square root of A is greater than or equal to 0. Now root A is only real if A is greater than or equal to 0. Addition and subtraction of surds. Only like surds can be added or subtracted. Examples. So question 1, 2 root A plus 5 root A, and we're going to try and add these together. So looking at this, we've got 2 and the surd is root A plus 5 root A. These surds are like surds, so we can add the coefficients together in front. So 2 plus 5 is 7 root A. Question 2, 5 root 2 minus 3 root 2. Question 2, 5 root 2 minus 3 root 3. Notice that the surd in or next to the 5 is root 2, but the surd next to the minus 3 is, in fact, root 3. So notice that they're not like surds. Therefore, cannot simplify. So that's as simple as it's going to get. Example 3, 5 root 2 minus 2 root 7 minus 4 root 2 plus 3 root 7. What you find is that we've got two different flavors of surds here. So we've got the ones with the root 2, and then we've got the surds with the root 7s. Notice that we can only add and subtract the surds that are like. So if we rearrange this around, we'll go 5 root 2 minus 4 root 2 plus, we'll go plus 3 root 7 minus 2 root 7. Evaluating what we have here, the 5 root 2 minus the 4 root 2, that's going to be 1 root 2 plus 3 root 7 minus 2 root 7, that's going to be 1 root 7. And remember in algebra, when we have a 1 in front of the pronumeral, we don't need to include the 1, it's implied. So it's the same with surds. We can get rid of the 1 here. So we say goodbye, goodbye, and goodbye. Like so. So the answer would be root 2 plus root 7. Now going downwards, multiplication of surds. So multiplication of surds follows the rule A root B times C root D is equal to AC, and then in the square root or inside the radical we got BD. And this only works such that B and D are greater than or equal to 0. So we can't have a negative number inside that radical. Now, for the examples, example 1, root 3 times root 7. Following this rules that we just mentioned above, root 3 times root 7, that simplifies down to square root of 3 times 7, and that becomes root 21. Question 2, 4 root 3 times 5 root 2. Again, that will be 4 root 3 times 5 root 2. And that will equal 4 times 5 Then in the radical we get 3 times 2, so it will become 20 root 6. Moving downwards, 4 root 3 times root 2 plus 2 root 5. So to solve this one, we need to use the distributive law. So 4 root 3 times root 2, and then plus 4 root 3 times 2 root 5. So this will become 4 root 3 times root 2 plus 4 root 3 times 2 root 5, like so. Simplifying that, the 4 multiplied by the 3 times 2 in the radical, plus 4 times 2. Then in the radical we have 3 and the 5. Simplifying, 4 root 3 times 2 is 6, plus 4 times 2 is 8. Then in the radical we have 3 times 5 is 15. And because notice that the root 6 and the root 15, they're not like, so they can't be added together. So this is as simple as it's going to get in this particular example here. Moving across, we've got in parentheses root 2 plus root 3 all squared. Notice the form that this is in that it is a perfect square. So if you remember back to the polynomials topic, to expand out a perfect square, we can go a plus b all squared, and that will expand out to be a squared plus 2ab plus b squared as such. Now using this form we've got over here, we can say, we can go shorthand and say a squared, so root 2 all squared plus 2 times root 2 times root 3 plus b, so in this case root 3 all squared. Then evaluate that. So root 2 squared is simply 2, gets rid of the radical, plus 2 times root 2 times root 3, so that's 2 times 3 is 6, plus root 3 squared, gets rid of the radical again, becomes 3, and collecting like terms, it will be 2 plus 3 is 5, plus 2 root 6. Perfect. And then example 5, we've got 6 plus 2 root 5 and 6 minus 2 root 5, and they're being multiplied together. So in example 4 we saw the perfect square. In this one we see the difference of two squares. So a plus b times a minus b. And we know that the rule for this is going to be a squared minus b squared. So this little rule will help us expand it out in the shorthand version. So in this case our a is going to be 6 and our b is going to be 2 root 5. So what we can say is the expansion of this will be 6 squared minus 2 squared root 5 squared, like so. That will be 36. 2 squared is 4 root 5 times 5. So we can get rid of that and simply go 4 times 5, 36 minus 20, that will simply become 16. So that will bring this video to an end. In the next video we'll have a look at the concept of simplification of surds.